Well, greetings, mathletes, and welcome back. We're going to be talking about trig identities today. Now, an identity is an equation that has the property that no matter what value you assign to the variable, the equation's true. Now, you've seen these before. They show up in algebra. Those are the equations that have solutions, all real numbers. Those are a type of identity. What we're going to be focusing on is the trig identities because what they end up being substitutions you can use for other things. So today's game, and it is kind of a game, um, we're going to be presented with things that we're told are identities, and what we need to do is prove their identities using the things we already know. Okay, so there's a few identities we do already know, and I put that in a worksheet for you. And this is the worksheet. Um, now, the the thing about this worksheet, we haven't actually seen all of these identities yet. So the ones we're actually going to be using, or the ones that are permissible to use, so to speak, um, are pretty much everything above. Oops, I turned the pen on, right? Everything above this line. So these guys we're not going to be using. Um, I guess technically you might be using some of these right here, but not really. So um, they are fair game. Uh, okay, so let's go ahead and erase some of this because I only want the stuff here that we actually need. So let's go ahead and get rid of that. Yeah, that'll work. And then we'll just go ahead and get rid of this. And honestly, there's no better way to do this than to just jump in and start doing one of them. So, um, basically, some of the strategies here are to rewrite things as sines and cosines, right? Because all of the trig functions can be rendered in terms of sines and cosines, either through what do you call it, the quotient identities, or through the reciprocal identities. You can write all of the trig functions in terms of sine and cosine, and that usually gives us a leg up when we do that. So let me go ahead and get rid of those. Now, let's go ahead and actually take a look at our first example. And we'll keep this one kind of straightforward so you can see how this works. So what we want to do is prove that sine, oops, sine theta, there we go, sine theta times secant theta is equal to tangent theta. Okay, so I look at this, and you need to have a sense of how to get from one side to the other. So this is an example of using the definitions in terms of sines and cosines. So if we turn everything into sines and cosines, we can get a hold of this thing. And keep in mind, there are more than one way to do this. There are several ways to do all of these. So sine is already a sine function. Okay. Secant, if I look at my reciprocal identities, secant is 1 over cosine theta. So this is now times 1 over cosine theta is equal to tangent theta. Well, if I multiply these two, I get sine theta over cosine theta equals tangent. And because of the fact that that is already a known identity, as a matter of fact, I can pull it up right here, right? That's one of the things that we've accepted to be true. So that means that we have just proven that sine times secant is also equal to tangent. Now, there's more than one way to do it, too. Like I chose to operate on the left-hand side, but I just as easily could have chosen to operate on the right-hand side. So I'm going to walk back again. We'll just look at it one more time and show that I can do this from the other side as well. Okay, so let's say I manipulate tangent. So sine theta times secant theta equals, well, let's see, tangent is sine over cosine. Okay, well, we can split those. So let's see here. This would be the same thing as sine theta times 1 over cosine theta, and 1 over cosine theta is secant theta. So this is now sine theta times secant theta is equal to, and I'm just going to drop this part down, is sine theta times secant theta again. Right? So, because both sides are identical, and this is the word identical is actually where the word identity comes from, we have just proven that this is true a second way. Okay, so that's the idea. We want to basically take these equations and work them in a number of different ways. We could be using lots of stuff, so we're going to see lots of techniques, but we want to work them until we get one side to match the other side. Sometimes we work on both sides at the same time. Sometimes we work on one side till it turns into the other side, and sometimes we work the other way. So there's different strategies as far as this goes. Okay, so let's go ahead and look at the next one here. And let's see here. So the next one says that cotangent of negative x, let's see where to go, times sine x is equal to negative cosine x. Okay, so again, we have a negative x here, right? We want to get this side to match this side, or vice versa. This is the more complicated side, so that's the side I'm going to try to simplify. But again, there's a number of ways to do these. It's just a matter of where you get a finger hold so you can move forward. But I see a negative x here. Okay, so that makes me think about the odd and even properties, right? The odd and even properties basically tell you how to deal with negative angles, right? And you can see here, if I have sine of a negative angle, I can basically pull the negative out of sine. Cosine, the negative just goes away when I have a negative angle. Tangent and cosecant, you can pull the negative through, and same thing with cotangent. So it looks like cosine and cosecant are the only ones that nullify the negative. So what does cotangent do? Let's see. So it says that cotangent negative x is equal to negative cotangent x. So that means I can substitute a negative cotangent x for this. So this is now negative cotangent x times sine x equals negative cosine x. Well, that's good. The negatives match now, right? So now we just have to see what we can do with this. Cotangent is cosine over sine, and it's negative. So, and that's times sine. And so we're going to treat this sine x as its own thing, right? And we can cancel it out because we can just cross cancel here. And that gives me negative cosine x is equal to negative cosine x. And we're winners, right? We just proved that cotangent of negative x times sine is equal to negative cosine. Now, the reason we're doing a lot of this stuff is because we're building up to solving equations. And many times in equations, you need to be able to rewrite it so it's in a certain form so that you can solve it. Oftentimes, you're rewriting it so that you can factor the expression. We'll see some of those today, too. Not solving the equations, but having to factor things. Okay, so let's make things go a little bit, let's get a little crazier here. So let's say I have cosine squared x minus sine squared x, and I want to show that that is equal to 1 minus 2 sine squared x. Right? So this one's a little more complicated. We're already everything's already in terms of sines and cosines, right? So there's different ways that we can approach this, right? And I'm just looking at this, I can see a couple of things right off the bat. So first I'm going to start with the more complicated way, okay? Now we have these Pythagorean identities, and the basic one says that sine squared x plus cosine squared x is equal to 1. Well, That also means that I can make substitutions here. For example, cosine squared x. Now you notice up here, um, I have a cosine and a sine, but the right-hand side only has sine. So the best thing to do would be to try to get cosine to look like a sine. And if I do that, I can go ahead and subtract sine x over, and I get cosine squared x is equal to 1 minus sine squared x. Well, that actually, let's see, that's a pretty nice substitution. So what I'm going to do is I'm going to take this cosine squared, and I'm going to write it as 1 minus sine squared x, right? So that's cosine. And then I have minus sine squared x again. And if I just go ahead and collect these like terms, I get 1 minus 2 sine squared x. Well, that's the right-hand side. Right? And so we've just proven this identity by making a substitution. Right? And that's pretty nice. Now, the other way we can approach this is by turning it into another identity that we already know. So you can be creative with these things. So let me go ahead and I'm going to erase this. Okay, so I want to look at the same thing one more time here. Let me go ahead and get this off of here. Now, basically what I'm going to do is I'm going to take the sine squared and I'm going to put it on the same side as the cosine squared. If you happen to notice, if I do that, what I'm going to end up with is this identity. Notice it has the sine squared and the cosine squared on the same side. So if I add 2 sine squared x to both sides, what I end up with is cosine squared x plus sine squared x is equal to 1. Now that's the nice way to do it, right? But I don't think it's I don't think it's as completely obvious as some of the other ways. So you can be creative with these things. There are more than one way to get a hold of these. And the fact that this is a true, right, that's the same as this identity right there. If you get it down to an equation that's already on your list of accepted identities, you win. Okay, so this really is like a game. Can I make this? Can I show that that's a true statement using these true statements? Right? Are they truly consequences of these other things? Okay, so let's go ahead and take a look at the next one here. Okay, so let's see here. We got pen on. So let's say I have cosecant squared, let's make it of x, over cotangent x is equal to cosecant, I got to write that correctly. Where to go? Cosecant x times secant x. Okay, now, since we've seen a couple of examples already, I want you to go ahead and attempt this one on your own. See what you can do with it. We've seen a couple of strategies. And just to point things out, you could work out some substitution with secant squared, since you have a secant squared in there. You can rewrite things as sines and cosines. Right? Those are the strategies that we've seen so far. You may see something else that'll get you through. There's actually a way to do all of these with geometry and just proving them from the unit circle, but that's that's a little advanced. But if you could do it, I would be super impressed. In fact, I'd be wondering what you were doing in this class if you could. So, in any case, let's go ahead and see what you got here. So go ahead and pause it. Okay, so let's see what we got here. My gut reaction for this is to write everything in terms of sines and cosines. And I'll be honest, most of the time when I work on identities, my first reaction is to write things as sines and cosines. That's the first thing I do almost every time. Here's the thing you have to be prepared for. What you try the first time may or may not work, right? These can be very frustrating because you start at one point and you work your way in a big circle and you realize you just ended up back where you started and you didn't get anything done. So you need a different strategy. So these can be frustrating. I encourage you to come and see me about them. But let's go ahead and see what we got here. So we got cosecant squared over cotangent. Okay, so I'm going to rewrite cosecant squared and cotangent. My strategy is to rewrite the left-hand side to see if I can make it look like the right-hand side. So let's see, cosecant, if we look here, is 1 over sine. So this is now 1 over sine squared. Keep in mind, the 1 is actually squared too, but 1 squared is 1. So that's cosecant x, and I'm dividing that by cotangent, which is cosine x over sine x. Okay, so what we need to do here, I think, if we're going to do anything, is flip this bottom and multiply. So we have 1 over sine squared x times sine x over cosine x. This sine will cancel out with one of these sines, right? And so now what I have is 1 over sine x times 1 over cosine x. And that is equal to, well, 1 over sine is cosecant. 1 over cosine is secant. Right? And so basically we just walked through and simplified the expression until we got the other side. Right? And this is a little messy. If you were going to write this up for a paper or something, you'd want things to look nice and in line. But again, one of the things that you're going to run into trouble here is losing control of the problem and just computing wildly. So you really have to think about why you're doing each step, right? And that's hard to do. It really is. Because sometimes you're just trying it to see if it works. You don't know why you want to try it, you just do. And that's okay too, because there's something to be said for a gut reaction to things. Okay, so let's take a look at the next one. Now, this next one is actually one that's going to require some factoring. So let's take a look at this. So we have sine to the fourth t minus cosine to the fourth t is equal to 1 minus 2 cosine squared t. Well, that's something, isn't it? Okay. Well, let's see here. Now, I've seen something similar to the 1 minus 2 cosine squared t before. We saw that 1 minus sine squared t thing. So there's probably we're probably going to be using this same identity at some point, right? Whenever you have a 1 minus a cosine or a sine squared, you usually end up using this Pythagorean identity over here. So, but the problem is we're not really in that position right now. We have this thing to deal with. Now, this is one of those times where you may or may not be able to see that far ahead, but if you factor this, it turns out one of your factors goes away. So let's take a look here. So sine to the fourth t and cosine to the fourth t, they're even powers, which means you can rewrite them as a square. Because this is the square of sine t, and this is the square of cosine t squared. This is the square of sine t squared, and this is the square of cosine t squared. Because of that, that makes this the difference of squares, which means I can rewrite this as sine squared t minus cosine squared t times sine squared t plus cosine squared t. Now I'm just working on the right-hand side, or the left-hand side right now. The right-hand side I'm just going to leave static, and I'll bring that down later. Well, looking at these two factors, right here, with our Pythagorean identity, it says that if I add sine squared to cosine squared, that is the same thing as the number 1. So I can just get rid of this and call it 1. So now I have sine squared t minus cosine squared t is equal to 1 minus 1 minus 2 cosine squared t. Okay, So I'm going to use the same trick I did before because we saw this before, but it was cosine squared minus sine squared. What I ended up doing before was, let's see, this answer is in terms of cosine, so that means I need to substitute to get rid of the sine. So if I look at sine squared t minus plus cosine squared t equals 1, let's see, what can I use to substitute for sine? Well, if I subtract the cosine over, I get that sine t is 1, or sine squared t is 1 minus cosine squared t. Right? So that means I can put that in. So now this is 1 minus cosine squared t minus cosine squared t. And if I combine those, I get 1 minus 2 cosine squared t. Well, wait a second. That's my right-hand side. Right? So now I have a full identity here. Right? Don't be too frustrated if you run into a dead end. Some of these can get very, very tricky, and you have to be pretty creative to get through them. But that's what you're learning right now, is how to be creative. And there's no way I can tell you how to be creative. You just have to try stuff and start figuring out what works and what doesn't. Right? This is really an experience thing, as far as being good at these. There's very few people who just walk into these, look at them, and naturally know what to do with them. Okay, so I want to look at the toughest one at this point. Right, this one was the one that, let's see here. I want to make sure this is going to take a little bit of room. So I have 1 minus sine squared t over 1 plus cosine t is equal to cosine t. It looks a little bizarre. I had to push my pencil around a bit to get to the final answer to this. So I do want you to attempt it. So go ahead and pause your video here and give it a shot. See what happens. If you can get it to match up, awesome. If you're still having trouble, well, then we're going to look at this in a minute. So go ahead and pause here. Okay, so let's see how you did on it. This was a pretty good one, so it might have taken some poking around to get through it. I'll try to walk through my thoughts as I solved this. So first thing I'm thinking is that this right-hand side is a single term, and I have two terms over here. So perhaps if I combine these into a single fraction, things will reduce so that I can get a single term. Right? So that's my first goal. I can't see that far ahead whether that's going to work or not without writing it down. So that's what I'm going to do. I'm just going to try it and see what happens. There may be more things I have to do to get things to work down, but I'm just going to see. So one, I'm going to find a common denominator here, and that would be 1 plus cosine t over 1 plus cosine t. Oops. Right? And so that's the same as 1. Basically what I did was I multiplied numerator and denominator by 1 plus cosine t so that it would match the denominator over here. Okay, and I'm not going to work on the right-hand side. I'm just going to save that for right now. But you notice I have a common denominator now, so I can write it as a single fraction. 1 plus cosine t minus sine squared t over 1 plus cosine t. And remember, our goal is to see if we can simplify this expression down to just cosine. Right? I want it to just look like cosine t when I'm done. Well, I have a problem. This doesn't reduce, and I have a sine squared t in here. Right? So whatever I write, if it has sine squared in it, it's not a cosine. So I need to rewrite this sine squared as a cosine. What I'm going to use is this same identity once again, the Pythagorean identity. So the Pythagorean identity tells me that sine squared can be written as 1 minus cosine squared. Oh, I wrote x and then I wrote t, right? Okay, so if that is the case, then I can substitute that in here. So I have 1 plus cosine t minus 1. In fact, I'm just going to distribute this negative as we go here. So the minus gets distributed across this. So it's minus 1, and then the minus times a negative cosine makes it plus cosine squared t. Now, that's still over 1 plus cosine t. Still not looking great, is it? Well, let's see what we got here. I have a little room here, so I think I can simplify things down. 1 minus 1 goes away. So that gives me cosine t. Actually, I'm going to reorder these. I'm going to put the cosine squared first, plus cosine t, and you'll see why I did that here in a second, and then 1 plus cosine t. Now, the next line, you notice both of these terms here have a cosine in them. So that means I can factor a cosine out. So now this becomes cosine t times 1. Oh, I wrote it in the wrong order. Oh well. I'll hang on here. Times cosine t plus 1 over 1 plus cosine t. And 1 plus cosine t is the same as cosine t plus 1. So I can cancel that out, and that leaves me with cosine t. Okay, so that was the longest one that we've worked on. And notice I did not know how the whole, well, I did know how the whole thing was going to progress because I worked it out ahead of time. But when I first started it, I didn't know exactly what the solution was going to be. So I knew that finding a common denominator would change the form and change it to a form that might be simplifiable, right? And so I did that, and I didn't see anything obvious, so I had to turn back to my identities over here to see if there was something else I could use to simplify things. And then it just turned into a whole bunch of algebra. And we had to use the algebra to simplify things. But I do want to emphasize that you can, in your mind, when you have a cosine t, you can think of that as a single variable because we're not solving these for t, right? What we're trying to do is just get the right-hand side to match the left-hand side. And so what it becomes is a game of massaging the algebra. So you have to be good at the algebra. You have to know the identities, right? Because at some point there starts to be too many identities to have to look them up all the time. I mean, oftentimes that is what ends up happening. But you really do want to have these memorized. The place that these are going to be used the most, you do use them in calculus and you use them in pre-calculus, but Trig is really, really heavily relied on in second semester calculus and up. So you really need to have this stuff down especially if you're planning to progress up to the second level of calculus. So in any case, that'll wrap it up for today. And so until next time, keep your pencils and your wits sharp.